Today we're going to be looking at quadratic functions. So the standard form of a quadratic function is y equals ax squared plus bx plus c. So the simplest form is called the parent function, which is y equals x squared. So a, our coefficient, is just a 1. And that's always starts at the origin of 0, 0. So a quadratic form, it's a U shape, but it's called a parabola. So we're going to figure out what happens when a is a value other than 1. So let's graph each of these 1, 2, and 3. So right now we have a does equal 1, so we're going to be graphing the parent function. So if we just start with 0, 0 squared is 0. If I plug in a 1 for x, 1 squared is 1. If we plug in a 2, 2 squared is 4. And then 3 squared would be 9, so we can't fit that on the graph. So then let's go to the other side. So if I plug in a -1, -1 squared is a positive 1, because -1 times a -1 is positive 1. -2 squared is a positive 4. So this is our parabola for our parent function. So now let's take a look at number 2 and see what happens when a is now a 2 instead of a 1. So we're going to start with 0 again. So 0 squared is 0, and 0 times 2 is 0. So we're still at the origin. If we take 1, 1 squared is 1, and 1 times 2 is 2. So we end up with 1, 2. If we take 2, 2 squared is 4, and 4 times 2 is 8. So we're going to be up here outside of our graph. So then if we go -1, -1 squared is a positive 1, and positive 1 times 2 is 2. -2 squared is a positive 4, and 4 times 2 is 8. So we're here. So we end up with this parabola in here, and I'm going to highlight it just so I know that that one is what it matches. Alright, so now let's look at number 3. Start with 0. 0 squared is 0, and 0 times 1/2 is 0. 1 squared is 1, and 1/2 times 1 is a half. 2 squared is 4, and 4 times 1/2 is 2. 3 squared is 9, and a half times 9 is 4.5. So we go the other way. -1 squared is a positive 1, times by 1/2 is a half. -2 squared is a positive 4, and positive 4 times 1/2 is 2. -3 squared is a positive 9, times by 1/2 is 4.5. So then here is our parabola for number 3, and I'm going to highlight it so that I know that's the graph it matches. So let's look at number 4. It's working with the parent function, however now we have a negative. So let's see what happens when we end up with a negative for our a. So if we plug in 0, 0 squared is 0, times by a -1 is 0. 1 squared is 1, times by a -1 is a -1. 2 squared is 4, times by our -1 is a -4. And then the other one's going to be off the page. So then this one, if we take -1, -1 squared is a positive 1, times by this negative is a -1. -2 squared is 4, times by a negative is a -4. So that's our parabola. So let's look at number 5. It's the same as number 2, where our a value is a 2, but now it has a negative. So what's going to happen to that? So if we take 0, 0 squared is 0, times by -2 is 0. 1 squared is 2, times by -2 is a -2. Sorry, 1 squared is 1, times by -2 is -2. 2 squared is 4, times by a -2 is a -8. So then -1 squared is 1, times by -2 is a -2. -2 squared is 4, times by a -2 is a -8. So as you can tell, it's still got narrow because of that 2, but now it's reflected over the x-axis. Alright, let's look at number 6. So we're still going to be starting at the 0, because 0 squared is 0, times by negative 1/2 is 0. 1 squared is 1, times by negative 1/2 is a negative half. 2 squared is 4, times by a negative 1/2 is a negative 2. 3 squared is 9, times by negative 1/2 is a negative 4.5. So the negative 1 squared is 1, times by negative half is a negative 1/2. Negative 2 squared is 4, times by a negative 2 is a negative 2. Negative 3 squared is 9, times by negative 1/2 is a negative 4.5. So we end up with that. We're just now facing in a different direction. So what observations can we make about the effect on the function a? Well, it looks like when a is greater than 0, the graph narrows. And it looks like when a is less than 1, that the graph widens. And also what we notice too, when we have the negatives, if a is negative, then the graph reflects over the x-axis. Alright, let's take a look at the vertex. The vertex is the highest or lowest point of the parabola. So the maximum point is the highest point, and the minimum is the lowest point. So let's identify the vertex and tell whether it's a minimum or a maximum. So on this one, our vertex is here, and it's the lowest point on our graph. So we're going to call this the minimum. The value at our minimum, which is our y value, is at a 2. Here's our vertex on this one. It's the lowest point of our graph, so that's also a minimum. And the value at that, so the y value at this point is 0. So looking here, here's our vertex. It's the highest point, so it's our maximum vertex. And the y value is 8.